Hey guys, here are your writing sources for this week. Source number 1, motion in the ocean, big or small, sea animals are in step. The ocean is full of creatures very big to very small. If the sea were a dance floor, you would see some surprising pairs. Albatrosses measure up to 6 pounds. Pilot whales weigh more than 1,000 times more, about 6,600 pounds. To match the length of a hammerhead shark, you need to stack up 20 little penguins. And a polar bear would probably prefer to snack on a sea lion than dance with one. But a new study says that these very different animals have something in common. They move in similar ways. Scientists from around the world worked together on a new study. They wanted to understand how animals move around the ocean. To find out, they compared the movements of thousands of animals. They studied where the animals moved, too. The scientists found that ocean animals, both big and small, moved in similar ways. Body size and environment. How animals fly, scurry, or swim is based on two things. The first is their bodies, the second is their environment. Body size is important. Big animals usually run or swim farther than small animals, but smaller creatures may move more easily through a forest than bigger animals. Some animals live in sand or snow. Others live where it's not too hot or too cold. Throughout history, humans have been curious about how and where animals move. Tracking devices. Scientists today can use a new tool to understand animals. Tracking devices are tiny machines that can be attached to an animal. The device sends back signals. It lets scientists know where and when the animal moves. The new study used data from an earlier tracking device studies. These other studies were not only about animal movement, they were done on many topics. People who worked on these studies shared their data with the team studying animal movement. The scientists used tracking data from 2,600 animals. These animals traveled to nearly 3 million places around the world, so the scientists had a great deal of information to work with. They were able to ask questions about many kinds of animals. They could compare the fast-flying albatross to the fast-swimming shark. They could look at whale data and turtle data side by side. Similar movements. The results surprised the scientists. Earlier studies of land animals found that big animals move very differently from small ones. In the oceans, this was not the case. Environment was more important than body size. One animal could be thousands of times larger than another, yet they both moved in similar ways. Some animals hunt for food, others eat kelp or ocean grass. Many creatures paddle, some swim, and some fly. But these differences didn't really affect how animals moved. Where the animals lived did affect their movement, though. Some animals, such as the beluga whales and green turtles, like the coast. These animals move in complicated ways. They turn often and repeat their steps. In the ocean part, in the open ocean, things are simpler. Animals there, like black-footed albatrosses and whale sharks, will pick a spot in the distance, then they shoot straight forward toward it. For all kinds of animals, how they move is affected by their environment. For sea creatures, the ocean plays an especially big part. Seawater surrounds animals on all sides. Animals can float along the ocean currents. The ocean creates an uneven playing field for creatures of all different sizes and shapes. Playing field is changing. Today, this playing field is changing quickly. Ice at the North Pole is melting. The coasts are rearranging. Sea levels are rising. Scientists hope that understanding how animals move will help us predict what they might do in the future. They think animals living along the ocean shore might adapt better to changing coastlines. Animals who live in the open ocean may have more trouble. Now scientists better understand how animals move through the ocean. They can use this information to make predictions about endangered animals too. These are animals at risk of dying out forever. Scientists and many others want to protect animals big and small. Knowing how they move may help. Scientists find a bright spot in the dark, deep water, a new type of neon fish. A new fish has been discovered in the deep waters of the ocean. It is brightly colored and lives in the ocean's twilight zone. The twilight zone is far below the water surface and is very dark. Scientists think the fish is so beautiful that they named it Tosinodes Aphrodite. In Greek myths, Aphrodite is the goddess of love and beauty. Scientists from the California Academy of Sciences found the pink and yellow fish off the coast of Brazil in South America. Scientists are excited because it is a new type of Tosinodes fish. It is the first Tosinodes fish to be found in the Atlantic Ocean. The bright creature adds an unexpected splash of color to a normally dull environment. Scientists enter the twilight zone. Fishes from the twilight zone tend to be pink or reddish in color, said scientist Hudson Pinero. He's an ichthyologist or fish expert at the California Academy of Sciences. He helped discover the new fish. He explained that red and pink light does not reach very far below the water's surface. This means that red and pink fish in the twilight zone are harder to see. This protects them from animals that want to eat them. According to National Geographic's Michael Greshko, Pinheiro and his fellow scientist Luis Rocha, also an ichthyologist, were exploring a coral reef. They were about 400 feet below the St. Paul's Rock stretch of island. As they were swimming, the scientists caught a quick look at the fish flashes of pink and yellows. They were surprised by the bright colors and decided to swim after it. Soon the scientists found themselves face to face with a 3-inch T. Aphrodite. They were so enticed by the new fish that they didn't notice a huge shark swimming above. The only tastanodes in the Atlantic. By the end of the summer 2017 dive, Pinheiro and Rocha had a collection of the new fish. They had 3 adult males, 2 adult females, and 2 young females. With the help of scientist Claudio Rocha, the team ran tests to see what other animals it is related to. The scientists also studied its behavior. Based on these lab tests, the scientists identified the fish as a member of the Tostanodes genus. Genus is a category of animal that is larger than its species. Animal species is the same genus are related. T. Aphrodite is the 4th species to join the Tostanodes genus of fish. It is the only Tostanodes ever discovered in the Atlantic. The other 3 Tostanodes fish species live in the Pacific. They include Tostanodes obama, a Hawaiian fish named after former U.S. President Barack Obama. The male fish stand out. T. Aphrodite males are much more colorful than the females. The females are a solid red-orange color. They look more like other fish in the twilight zone. It is unclear why these species develop such unusual colors. Luis Rocha said that at first the scientists thought the colors helped the fish hide in the dark ocean. Since the males and females are so different, though, Rocha thinks that there must be some other reason. They are studying the fish's eyes to find out. Dream job as ocean explorer. Michael Lombardi dives to some of the world's deepest coral reefs. A coral reef is found underwater. It is where many different sea plants and animals live. Lombardi's job is to dive and study what he sees. One of the places Lombardi often dives to is a reef in the Bahamas. This is a group of islands near Florida. To help with diving, Lombardi invented an underwater tent. It makes it easier for divers to come back to the surface without getting sick. Divers can get sick if they come up to the surface too fast. Early work. Lombardi grew up in the U.S. state of Massachusetts near Narragansett Bay. He often went there to fish with his dad and brother. Lombardi's father helped give his son a passion for the ocean. His dad was in the Navy, so he spent a lot of his time at sea. He would tell Lombardi stories about the ocean. While still in high school, Lombardi took a diving course. It was not very easy. I had a really hard time with the dive class, he said. I struggled with the swim test. I struggled with putting my face in the water for the first time. I struggled with the whole thing. Still, he wanted to be a good diver. It was going to be useful for the work he wanted to do. The hard work paid off. Because of his diving experience, scientists came to him for help on difficult dives. The most exciting part of your work. Lombardi said the most exciting part is being somewhere no one has ever seen. Some of these deep reefs have never seen any humans, he said. Most demanding part of your work. Lombardi says you have to be in very good physical shape, but there's more to it than that. In the deep ocean, a diver has to pay attention to everything. There's no room to make a mistake. You cannot relax. Portable habitat. When divers are done exploring, they have to come up slowly or they will get sick. Usually they have a rope running from a boat on the surface. As they come up, they stop at certain points along the line to rest. Lombardi made an underwater tent that can be filled with air. Inside are bench seats. It allows divers coming up from a dive to be more comfortable. Geoconnection. Lombardi hopes others will notice this unexplored area in the Bahamas. He often uses the Global Positioning System, or GPS. It can tell you exactly where you are on Earth. He says it helps divers map out where they are working and find new places to go. It can help them find something they lost underwater. Google Earth is another tool Lombardi is excited about. It's a digital or computer map of the whole world. He said it's something all explorers should be using. So you want to be an ocean explorer. Lombardi said students should study many different things. Ocean explorers do more than just study sharks and dolphins. They also work closely with people in geography, technology, and education. Lombardi thinks engineering will be important for exploring the ocean in the future. He does not think there will be enough engineers who understand how to explore the ocean. In other words, we need more of them.